Hey there, welcome to all those joining me for whatever reason you're joining me. Today I'm going to be going over a quiz for some of my clients that I made. This quiz includes fractional problems as well as greatest common factor, least common multiple, and one word problem that deals with fractions. So what I'm going to do is go over each problem individually and kind of go over the steps, starting with problem number one. So problem number one is 1 1/4 plus 2 2/5. So we have 1 1/4, 1 1/4 plus 2 2/5. So here, just by looking at the denominators in both fractions, we have 1/4 and 2/5. Those denominators are not the same. So we need to get common denominators. But before we do that, our first step is to change these mixed numbers into improper fractions. So we change 1 1/4 from a mixed number into an improper fraction. So we start with the denominator of 4, which shows that it takes 4 parts to make one whole. And then we see that number 1, which represents there is one whole. So we multiply 4 times 1, so 4 times 1 is 4, plus 1 is 5/4. Then we take our other mixed number, 2 2/5. That denominator of 5 shows that it takes 5 parts to make a whole. Our whole number of 2 says we have 2 wholes, so 5 times 2 is 10, plus the 2 from 2/5 gives us 12/5. So now we have, instead of mixed number plus a mixed number, we have an improper fraction plus the improper fraction. Remember, 1 1/4 is the same thing, same value as 5/4, just written in a different way. Same with 2 2/5 is the same as 12/5, just written in a different way. So we have 5/4 plus 12/5. Still don't have common denominators. So what we have to do is take the opposite denominator and multiply it times the top and the bottom for each fraction. So we're going to multiply 5/4 times the opposite denominator, which is 5. So we multiply 5 times 5 up top and 5 times 4 on the bottom, giving us a new fraction of 25/20. So for 12/5, we take the opposite denominator of 4. We're going to multiply that times the top and the bottom. 12 times 4 is 48 over 4 times 5, which is 20, giving us our new equation, 25/20 plus 48/20. Now, look at that, we got a common denominator. So next step is to add across the numerators 25 plus 48. So 25 plus 48 is going to give us 73. Remember, we don't add the denominators. They stay the same. That's the representation of how many numbers, or how many units make a whole. So we have 73/20. Next step would be to find out how many times 20 goes into 73 without going over. So what we can do is count by 20. So 20, 40, 60, 80. 80 is going over. So the number before 80 was 60. 60 is 3 groups of 20, so we know we have a whole number of 3. There's 13 left over, so we have 3 and 13/20. And that's going to allow us to arrive at that answer. So we had 2 mixed numbers. We had to change those into improper fractions, then get common denominators, add the numerators, and then turn our improper fraction of 73/20 into a proper fraction, or a mixed number that it came out to be, 3 and 13/20. So that was problem number 1. Is addition of fractions. Problem number 2 dealt with subtraction of problems. this problem was 4 minus 2 and 1/3, or 4 minus 2 and 1 over 3. So with these, again, we are going to have to change these fractions in order to get them to have a common denominator. Because what we have is we have a whole number, 4, minus a mixed number as a fraction. So what we can do is, remember, any whole number can be made into a fraction by putting it over 1. So to change 4 into a fraction, we just put it over 1, 4 over 1. Because remember, the denominator signifies how many units make a whole. So if only 1 unit makes a whole, and we have 4 of them, that means we have 4 whole numbers, or 4, like we just changed. So we have 4 over 1 minus 2 and 1/3. So we have an improper fraction minus a proper fraction, or minus a mixed number. We can't have that. So what we're going to have to do is change 2 and 1/3 into an improper fraction. So 4 over 1 stays the same, and then we add our minus sign, and then we change 2 and 1/3 into an improper fraction. So we look at our denominator of 3, multiply that times our whole number, times 2. So 3 times 2 is 6, plus our numerator of 1, so that would be 7 over 3. So now we have our equation, 4 over 1 minus 7 over 3. Can we subtract this? No, we cannot, because look at the denominators. We have 1 and 3. Those are not the same. They're not common. What we have to do is make it into a common denominator. So like we did last time, we're going to take the opposite denominator for each fraction and multiply it times the top and the bottom. So for 4 over 1, we take the opposite denominator of 3. We're going to multiply it times the top and the bottom. So 3 times 4 is 12. 3 times 1 is 3. And then for 7 over 3, we take the opposite denominator of 1. We multiply it times the top and the bottom. Remember, anything multiplied times 1 is itself. So this fraction is going to stay the same. 7 times 1 is 7. 3 times 1 is 3. So now look at this fraction, this subtraction problem. We have 12 over 3 minus 7 over 3. Definitely have common denominators. They are both 3. So now all we do, just like addition, we only use the numerators. We don't subtract the denominators. Those stay the same. So we have 12 minus 7, which would give us 5. So we have 5 over 3. It's an improper fraction, so we can't leave it like that. If we want, we have to change. We have to see how many times 3 goes into 5 without going over, which we know is 1 time with a remainder of 2. So that gives us a final answer of 1 2/3. So for this problem, remember, it's important, if you have to change a whole number, like 4, into a fraction, you just put it over 1. So we had 4 over 1 minus 2 and 1/3. We changed 2 and 1/3 into an improper fraction, which gave us 7 over 3. So our new equation looked like this, 4 over 1 minus 7 over 3. Then we had to do the exact same thing that we did in the addition problem to get the common denominators, which is taking the opposite denominator and multiplying it times the top and the bottom. Remember, what that's going to do is it's going to force you to multiply your denominators together, giving you the same exact number. And don't forget about the term equivalent fractions. So when we changed 2 and 1/3 into 7 over 3 as our improper fractions, 2 and 1/3 is the exact same value as 7 over 3, just written as a different way. They are equivalent fractions. All right. Number 3 is a fractional multiplication problem. We had 1 and 1/2 times 1/2. Now, it's important, well, it's not important, but one thing I remember about multiplication problems of fractions is that it is by far the easiest operation to do. It's not like addition or subtraction where you have to go through the problem of changing the mixed numbers into improper fractions and then getting the common denominators and then simplifying the fractions. For multiplication problems, what you do, like this, is we have 1 1/2 over, or I'm sorry, 1 1/2 times 1/2. So the first thing we do is we're going to have to change them into improper fractions. Well, at least 1 1/2, because 1/2 is already just, it's a fraction, it's not a mixed number, so we don't have to change that. So 1 1/2, when you change that into an improper fraction, 2 times the whole number of 1, 2 times 1 is 2, plus 1 is 3 over 2. So 1 1/2 is the same thing as 3 over 2 times 1/2, because remember, we did not have to change that. So 3 over 2 times 1/2. That's all you got to, well, that's not all you have to do. Now all we do is we multiply across the top and the bottom. So 3 times 1 is 3, and 2 times 2 is 4. So that gives us our answer of 3 over 4. That is a proper fraction, doesn't need to be broken down anymore, does not need to be simplified. So we can leave our answer as 3 over 4. So for multiplication problems, all you have to do is change the numbers into either regular fractions or improper fractions and then multiply across the top and the bottom. And then if you need to, you can simplify your answer, but you don't have to go through all the problems that you have to go through for addition and subtraction. Problem number 4 is a division problem. We had 7 over 9 divided by 1/2. So what this problem is asking is, how many times does 1/2 go into 7 over 9? So for divisional fraction problems, very similar to multiplication fraction problems, just with one step added. So what we have to do here is we take the second fraction and we flip it. So our numerator becomes our denominator, and our denominator becomes our numerator. So first fraction stays the same, 7 over 9. Second fraction changes, however. We flip it. So 1 over 2 becomes 2 over 1. After we flip it, that division sign then becomes multiplication. We then do some multiplication. So we have 7 over 9 times 2 over 1. Remember, when we are multiplying fractions, we're multiplying across the top and the bottom. That gets confusing because in addition and subtraction, you only add across the top. You don't add the denominators. In division and multiplication of fractions, we do multiply across the bottom. We do multiply the denominators. So 7 over 9 times 2 over 1, we multiply the numerator. 7 times 2 is 14. 9 times 1 is 9. We know 9 goes into 14 only one time without going over, with a remainder of 5. Our denominator stays the same of 9, so we come to our answer of 1 and 5 over 9. So quick review of all of those, because those are all of the operations, like we call them, addition, subtraction, multiplication, and division. So for addition, we change our whole numbers into improper fractions if we need to. If it was 1/4 plus 2/3, we do not have to change them into improper fractions. They're already fractions. All you have to do is find the common denominator in that matter. So, and then for subtraction, it's pretty much the same. You change your whole numbers into improper fractions if you have to, and then you get your common denominators, and then you subtract across the numerators, but you don't subtract your denominators. Imagine that if you got your common denominators, it was 1 over 2 minus 1 over 2, that would give you 0 over 0. That just does not make sense. And then for multiplication of fractions, what you do is if you have to, you find the improper fraction, you change a whole number into an improper fraction, and then you multiply across the top and the bottom. For division, very similar, but what you do before you multiply across the top and the bottom is you flip that second fraction, and then change that division symbol into a multiplication symbol. All right, moving on to question number 5. Excuse me. Question number 5 says, simplify the fraction 12 over 96. 12 over 96. So there's a couple of different ways to do this. What you can do is the long way, which is you can divide. I've noticed that the top and the bottom are both even numbers, so I can divide it by 2. So if I did do that, dividing the top and the bottom by 2, 12 divided by 2 is 6. 96 divided by 2 is going to be 48. So we have 6 over 48. Again, those are even numbers, so they can be divided by 2 to simplify. 6 divided by 2 is 3. 48 divided by 2 is 24. And then looking at that, I know that 3 is a factor of 24. So 3 goes into 3 one time, and 3 goes into 24 8 times. So 3 divided by 3 is 1. 24 divided by 3 is 8, so that gives us our final answer of 1 over 8, because it can't be broken down anymore. Another way of doing that is by looking at the numbers 12 and 96, and over time, you will notice that 12 is a factor of 96. 12 goes into 96 evenly. 12 also goes into 12 evenly one time. So 12 divided by 12 is 1, and 12 divided by 96 is 8. So just dividing, that first time we had to divide by 2 twice, and then by 3. So that was a lot of times dividing. This time we only had to divide one time. We divided 12 by 12 and then 96 by 12. We knew to do that because over time you will learn the relationships between numbers. I know that counting by 12s, we go 12, 24, 36, 48, 60, 72, 84, 96. And so I knew that counting by 12s brought us our factors of 96. So all the factors of 96, there's a lot of factors of 96, but we know that 12 is one of them. So that's the ways of simplifying. You can either divide the top and the bottom by numbers that go into them evenly until you can't divide or simplify it anymore. Like when we got to 1 over 8, we can't really break down 1 anymore. That's the most broken down it can get. Question number 6 was find the greatest common factor of 40 and 16. So the GCF 40 and 16. So I recommend starting with the lowest number. So we'll start with 16, and we're going to find all the numbers that go into 16 evenly. We're going to list them out, putting commas in between every one of them. So we always start with 1. 1 is a factor of every number. And then go on to 2. 2 goes into every even number. 16 is even, so we know 2 is a factor. 3 does not go into 16 evenly. We know that. We know it goes into 15 and 18. 16 is in between that. 4 does go into 16 4 times evenly, 4 times 4. What about 5? 5 does not go into 16 because 5 only goes into really numbers that end with 5 or 0. Think about it. 5, 10, 15, 20, 25, 30, 35, 40. All those numbers end with 0 or 5. Does 6 go into 16? I don't believe so. 7, no. 8? Yes. 8 goes in 2 times. So we're at that halfway mark, so we know kind of to stop there and add 16 as our last factor, because remember, every number is a factor of itself. So for the factors of 16, we have 1, 2, 4, 8, and 16. Next up, we find the factors of the number 40. So the factors of the number 40 are going to be 1, because 1 goes into every number, every whole number, that is. 2, because 2 goes into every even number. 3 doesn't go into 40. 4 does go into 40. So does 5, because it ends with 0. 6, it does not go in. 7, no. 8, no. Wait. Yes. So 8 does go into 40 evenly. 5 times. Sorry. Had a bit of a brain fart. So after 8, we know 9 doesn't go into 40. 10 does go into 40 evenly 4 times. 11, no. 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 does go evenly into 40 2 times. It's our halfway mark, so we know that's our second to last factor besides the number itself, 40. So 40 had quite a bit of factors. We had 1, 2, 4, 5, 8, 10, 20, and 40. So now that I have both of these numbers and their factors listed, I'm going to go through and circle all of the numbers that are included in both sets. So 1 is in both, 2 is in both, 4 is in both, 8 is in both, 5 is in 40. 5 is a factor of 40, but it is not a factor of 16, so I cross that out. 16 is a factor of 16, but it is not a factor of 40, so I cross it out. Same with 10, 20, and 40. So now I look for the biggest number that is circled in both sets of numbers. So I know that I circled 1, 2, 4, and 8. 8 is the biggest number, so that is the greatest common factor. Remember, greatest means biggest, common means shared factor. So it's a biggest shared factor between the two. And again, factors are numbers that go into other numbers evenly, or they can be multiplied together to get a certain number. So the greatest common factor of 40 and 16 is 8. 8 goes into both 40 and 16, and it's the biggest number that goes into both of them. So question number 7 is a similar question. It says, find the greatest common factor of 7, 15, and 21. So this time we have 3 numbers. So we have to find the biggest factor that goes into all 3 numbers. I'm going to start with the smallest number, 7. 7 is a prime number. So there's only 2 numbers that go into 7 evenly, and that is 1 and itself, 7. So 1 times 7. So we know that if we do find a greatest common factor for any of these numbers, it's either going to be 1 or 7. So now we go on to 15. 15, again, is a prime number. So the only numbers that go into 15, oh no, totally lied. 15 isn't a prime number. There's a lot of numbers going to 15. Another brain fart, apologize. So 1 goes into 15 evenly 15 times. 2 doesn't go into 15. 15 is an odd number. 2 doesn't go into any odd numbers evenly. What about 3? 3 does go into 15 evenly 5 times. 4, nah. 5, yes, because 5 goes into 15 evenly 3 times. Next up, 6, no. 7, no. 8, no. That's over the halfway point. No other number is going to go in evenly besides the number itself, 15. Next up, we find the factors of the number 21, all the numbers that go into 21 evenly. So we have 1, not 2. 3 goes in 7 times. 4, no. 5, no. 6, 7, we know because it goes in evenly 3 times. 8, 9, 10, 11, 12, 13, 14. No other numbers besides 1, 3, 7, and of course the number itself, 21. So again, now we have all of the factors for the numbers listed. We're going to go through and circle all of the ones that are in all 3 sets. So remember, it has to be a factor that is shared by all 3 numbers. So 1 is shared by all 3 numbers. 7 is a factor of 7, but it is not a factor of 15 or 21, so I cancel it out. 3 is a factor of 15, but it is not a factor of 7. So 3 is a factor of both 15 and 21, but because it's not a factor of 7, we cross it out. It's not shared by all 3. Remember, this greatest common factor has to be shared by all 3 numbers. 5 is a factor of 15, but not 21 or 7, so cross it out. And then 15 is also not a factor of 7 or 21. 7 is a factor of 21, but is not a factor of either of the other numbers, so we cross it out. Also cross out 21, too big to be a factor of 7, 15, or 21. So what's the greatest common factor? What's the biggest number that is shared by all 3 of these numbers? The biggest factor that's shared by all 3 of these numbers. Kind of a trick question because the answer is 1. 1 is the greatest common factor. Although it's the smallest number, it is the only number that goes into all three of these evenly. So our final answer would be 1. Kind of a trick question. Sorry if that tricked you guys, but with math, it's important to really think about these problems, and sometimes if you think that doesn't sound right, that sounds too easy, sometimes it may be, because like me, I like to throw trick questions at people. Question number 8. Find the least common multiple of 8 and 9. So the least common multiple, so the multiples of 8, what I would do is I would start out by listing maybe the first 7 or 8 multiples of 8. So it's going to require a lot of work. What you can do is you can use a calculator to do 8 times 2, or we start with 8 times 1, because that's the first multiple. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and we keep going, so 8 times every number in succession. So 8 times 4 would be 32, next would be 40, 48, 56, 64, 72, 80, 88, and I'll stop there. So I went up kind of a lot. And then we wanted to find the least common multiple of 8 and 9. So we found all the multiples of 8. Well, not all of them, but the first couple of rounds. Now we want to do the same thing for 9. So really what we do is we start at 9, and you can multiply times 1, then times 2, 3, 4, times 5, times 6, times 7. Keep going like that. Or if you know your times tables well enough, you just start counting by the numbers. So 9, 18, 27, 36, 45, 54, 63, 72, 81, and then last one would be 90. So here, we want to find the least common multiple. So we want to find remember, least means smallest, and again, common means shared, so it's the smallest shared multiple. So we want to find the smallest number that is shared by both of these. Not like the greatest common factor where you want to find the biggest number that's shared. Least common multiple, you want to find the smallest, the least big number that is shared. So 8 and 9 are not shared. 16 is not shared. 24. So what I'm doing is I'm going through the multiples of 8, and if it is not also a multiple of 9, I cross it out. 8, 16, 24, 32, 40, 48, 56, 64, 72 is shared. So I'm going to circle 72. So I just want to go cross out my multiples of 9 to make sure that there's no other multiples that are shared. So 18 isn't shared, 27 is not shared, 36 is not shared, 45 no, 54 no, 63 no, 72 yes. So I circle that number. And because that is the smallest number that is shared, we don't have to keep looking for anything else. Since 72 is the smallest number shared, that is our answer. 72 is the least common multiple. It's the smallest shared multiple between 8 and 9. So number 9 on our quiz is another similar question. So we want to find the LCM, or the least common multiple, of 9 and 15. So I'm going to start with 9, and I'm going to start counting by 9s again, maybe up until 72. So we go 9, 18, 27, 36, 45, 54, 63, 72. Quick observation about the numbers, the multiples of 9. So it goes 9, 18, 27, 36. So if you notice that from 18 to 27, the digit in the 10 spot goes up 1, but the digit in the 10 spot goes down, but the digit, never mind. I'm confusing myself, and I'm going to confuse you. Forget I said any of that. Now we're going to find, so we found the multiples of 9 up until 72. 9, 18, 27, 36, 45, 54, 63, and 72. Now we want to find the multiples of 15. Starting at 15, because 15 times 1 is 15. 15 times 2 is 30, times 3 is 45, times 4 is 60, times 5 is 75. And I'm going to stop there because we stopped at 72 earlier. That's around the same spot. So again, I'm going to start with 9, and I'm going to cross out the multiples that are not shared. 9 is not shared, 18 is not shared, 27 is not shared, 36 is not shared. Oh, but look at that, 45 is both a multiple of 9 and 15. So now I want to go back and just make sure that all the multiples of 15 before 45 aren't shared with 9. 15 is not shared, 30 is not shared, but 45 is, and that is the smallest multiple. So that's where we stop. We know that 45 is the least common multiple, or the smallest shared multiple, between the numbers of 9 and 15. So greatest common multiple and greatest common factor and least common multiple. So many brain farts today. I'm so sorry about that for you guys listening. But so the greatest common factor is the biggest shared factor between the numbers. And remember, the factors are numbers that multiply together to get a certain number. So all of the factors of a certain number are either going to be equal to that number or smaller. Multiples are the numbers of a certain number that have been multiplied times other numbers. So the multiples of 2 are 2 times 1, 2 times 2, 2 times 3, 2 times 4, or in other words, 2, 4, 6, 8, 10, 12, all those numbers multiplied. And so when you want to get the least common multiple, you want to get the smallest shared multiple between 2 or more numbers. Because remember, in question number 7, we found the greatest common factor between 3 numbers. So it is possible that they're going to ask you to find the greatest common factor or least common multiple between 3 or more numbers. All right, this brings us to our last problem. So our last problem is a word problem, but it's also kind of like a fraction problem. It goes like this. There are 18 males. There are 18 male clients at our work and 22 female clients at our work. What fraction of clients are male? So for this problem, we have to remember what fractions represent. So the numerator represents a part of the whole, and the denominator, the bottom number, represents how many units make up the whole. So if we want to find out how many males are in the class and turn it into a fraction, we have to understand what our denominator is going to be. So our denominator, again, is going to represent how many students are in the class, how many students make up a whole class. So we know there's 18 males and 22 females. So what we have to do is add those two numbers together, because the number of males and the number of females, or the number of males plus the number of females, is going to equal the number of people in the class. So 18 plus 22 is going to bring us to 40. So we know that there's 40 clients at our work. 18 of them are men, 22 of them are women. So how would we represent that as a fraction? We're looking for the fraction of males. So that would be, there's 18 males and there's 40 students overall. So our fraction would look like this, 18 over 40. We can't leave that as our final answer because it can be simplified. It can be broken down. So what I would do, typically with a problem like this, because I look at the numbers 18 and 40, and I can't really think of any factors that go into 18 and 40 evenly besides 2. So I'm going to divide the top and the bottom by 2 to give us an equivalent fraction. So 18 divided by 2 is 9, and 40 divided by 2 is 20. Now there's no other numbers that go into 9 and 20 evenly. This is as far broken down as we can get it. So we would arrive at our final answer of 9 over 20. Hope that is a good review for the quiz that we did. If you need to, and you are still my client, you can email me, or text me, or call me. And if you have any questions, I'll be happy to help. I hope this was useful, and I will talk to you guys later. Bye-bye.